we're working at solving things of the form ax squared plus bx plus c equals 0. We have factoring. And factoring is rare in real-world problems. If we were going to be looking at problems, which we're going to start looking at some of those once we have all the tools in our toolbox to be able to do that. Right now we don't. The majority of application problems, if you're thinking, really don't factor. Factoring is used for other things more than solving equations. It's used for formula manipulation most of the time, is where it's at. And the square root property, and this guy, we are looking at something of some quantity squared equaling some number. That's one thing that we look at. Or in the world of ax squared plus bx plus c, it's got to be of the form ax squared plus c equals 0. For the most part, no x term. So, you know, it's really rather limited, the square root property. However, we can spread out essentially what we can do with the square root property by doing something, and it's called completing the square. And what it does is it turns, we're going to be looking at trying to turn something into what we call a perfect trinomial square. So it's going to be it's going to be x either plus some number or squared or x minus some number squared. Now remember, we had problems where we used the square root property on it. That's what it amounts to. Now, here's the other thing. We're going to go through this process of solving by completing the square, but we rarely, if we're solving any quadratic equation, solve by completing the square. This is a good place to learn how to do it because it pops up other places where it's harder to learn how to do it. So here we go. So what does that mean? Well, if I just kind of take a look at what happens with good old x plus y, the quantity squared. We're going to need something that's going to enable us to be able to work with this. This is x plus y times x plus y, or x squared plus xy plus xy plus y squared. What I want you to see is this. Notice I've got two of these. And they're identical in the middle. The other thing that I want you to notice is this. Is that x is the square root of x squared. So it's the guy that's in the front, square root of this guy. And y is the square root of y squared. It's the guy that's in the back. So that's what x and y are. So when I look at the set of parentheses, x and y, when you go to multiply them together, that gives you your first and your last. You square the front, you get this. Square the back, you get that. So they're squares of what's on either end. But there's this strange little middle in here. So if I combine like terms, it's x squared plus 2xy plus y squared. Now what the key is this. This is double. So it's 2 times the square root of x squared, the square root of y squared. So it's double what I'm looking for. So if I were to say to you this, I want to turn x squared plus 4x into something which is a perfect trinomial square. do I want to do? Well, x is still x, so that says this guy is the square root of whatever is in the front here. The problem is I don't know what's in the back. I don't know what's there. But there is something that I do know, that 4x is the double of x and the thing I'm looking for. That's the guy I want. I want y. The 4x is the double of that. So how would I find him? Well, I could divide the x's out. Right? Because there's an x here and an x there. I can just divide those x's out. So what I'm looking for, which is y, is double because of the 2. So what am I looking for? So y is 2, but what has to go here? So that says what goes here is a 2. So that's easy enough. What goes here is essentially y squared, or 2 squared. And it's always a plus. Here the center sign is plus, so that's going to be plus. So what does this mean to me? This says take the coefficient of x divide it by 2. That gives you y. And if I want y squared, I just square both sides. So there is a formula, and this is how it works. If I have, and the coefficient of x squared, by the way, has to be 1, otherwise this doesn't work. And I'm looking at plus bx. In order to, and you're going to always add, because remember the last, if the signs for a perfect square, it's going to be a minus and a minus, or a plus and a plus. So if the middle term is plus, it's plus. If the middle term is minus, it's minus, right? So whatever happens, this is going to be a plus always. So what's going to go here? You're going to take the middle term, divide it by 2. Now this is to remove the doubling. Because remember that xy happens twice. I got to take it out. And then what goes there is I have to square it. So let's see how that works with something we already know. So we said, suppose we have x squared plus 4x, and I want to turn it into a perfect trinomial square. Square root of x squared is x. That's easy peasy. Center sign is plus. To find what's going to go here, I'm going to take b over 2 and square it. This is 4 over 2 squared, which is 2 squared, or 4. So that says I add 4. But if this is a 4, what's this guy? 2. Square root of x squared is x. Square root of 4 is 2. Sign in the center is plus. Now I have a perfect trinomial square. But what I have to have is just this part right here. Bless you.